On this one, finding BC, given that these two triangles are similar, find BE. We've got AB, here's AB. AB to BC is equal to AE to ED, find BC. So AB is 12, BC is what we're looking for, AE is 18, and ED is 15. And you would set it up just like that. I would reduce before I get started, so it's going to be 6 over 5. So 6x is equal to 60. X will be equal to 5. X will be equal to 10, rather. That's a little crazy. So BC is equal to 10. On this one, given that AB is to BC just like AE is to ED, find BC. So I've got 6 over x is equal to 12 over 4. Again, you can reduce right now. This is a 3, this is a 1. 3x is equal to 6. So x is equal to 2. So again, BC is equal to 2 will be our final answer. Moving on, scale factor, find it. They're similar. This has been rotated, so really it's going to be 8 to 10. 8 to 10, and that's going to reduce down to 4 to 5. Find the values of x, y, and z. Y is going to be the easiest. We'll put these over here. Y is going to be the easiest. It's 10 and 10, so this is going to be 8 and 8. X, I'm going to set up the ratio. So 8 is to 10, just like 12 will be to x. So 8 to 10, just like 12 to x. Let's reduce first. I've got a 4, I've got a 5. I can reduce right here, a 1 and a 3. So I've got 15 for x. You can also cross multiply from right there and get 60 is equal to 4x, and then divide that out if you wanted to. Find the perimeter of x, y, z, this one over here. So I've got 20 times 2, so 40. Perimeter is 40. Find the perimeter of MNOP. So 10, 15, and 15. I've got 25 times 2, so 50. You can also use the ratio for that. Find the ratio of the perimeter. Oh, I didn't find z yet. Z is going to be 135. They're the same angle. Find the perimeter. The ratio of the perimeter is 40 to 50. It's still going to be 4 to 5. Still going to be 4 to 5 on that one. And you can just set them equal to each other and reduce just like we did over here. But you really don't have to. Because if the length ratio is 4 to 5, the ratio of the perimeter is also going to be 4 to 5. Say whether or not the triangle is similar. So remember, we got angle, angle, angle. That'll work. Side, side, side. That'll work. And angle, side, rather. That will also work to prove triangle similar. 43 and 47, they're not the same, but I can look and find this other one. This is going to be 47. This is going to be 43. Using the interior angles equal 180. Here's 47. Here's 90. The rest has to be right here. So you'll notice I've got two angles that are the same. 47, 43. I've also got a third, which is 90. This is yes, and it's angle, angle. We'll prove it. This one is going to be no. And the reason we know for sure, 35 plus 63, this angle and this angle, they will not match. They will not match because this is 35 and 73. They will not be the same. You can do the math on that if you want to. Not going to match. This one down here, I've got vertical angles that are the same. I've also got alternate interior angles that are also the same. So we get all three to be congruent, but we only need two to prove similarity. This next one, I've got an angle, and the sides hold a ratio. 3 to 12 is the same as 4 to 16. So the sides hold a ratio in my angle, side angle. This is going to be a yes, and I apologize, and it's going to be a side angle side on that one. Let's go to our final page. How exciting. This one, AF is to FC, just like what is to DB. So again, we start here. Means we're going to start over here. We move up. We move up. This one's going to be EB. Next one, AE, I think of it as the bottom of the big triangle, is to CD. I apologize. AE is to CD. Again, bottom of the big triangle, bottom of the little triangle. Just like GE the right side of the big triangle is to what? And it's going to be GD, the right side of my little triangle. And the next one is just the reverse of this. So I've got GD is to GE, little triangle, big triangle, just like what is to AE. So if this is the big triangle, CD is going to be that little triangle. And you'll notice 56 and 57 are identical. They're identical, they're just reversed order. This one, they should have the direction of find AB on all of these. Lots of different ways to do it. I'm going to show you my personal favorite way. I think of 58 as similar triangles. So if I'm looking for AB and I think of it as X, this is the bottom of these two triangles. So 9 is to X, just like 10 is to 18. Again, bottom of the big triangle, bottom of the little triangle, side of the little triangle, side of the big triangle. And then I'm going to cross multiply and solve. So first, I'm going to divide by 2. That gives me a 5 and a 9. I'm going to get 81 is equal to 5x. So x is going to be equal to, that's going to be 16.2. 16.2. This one, gracious, I'm going to have to get a calculator. I've got 35 is to 21, just like 40 is to x. I'm going to go grab one real quick. Alright, and we're back. We're going to punch out the math. So I've got 840x, or 840 is equal to 35x. So I've got 840 divided by 35 is going to be 24. So x is equal to 24. My last one, this one you're going to have to remember the ratio. So I've got x is to 30, x is to 30, just like 52 is to 20. So just like 52 is to 20. X is to 30, just like 52 is to 20. This means that 20x is equal to, I want to say it's 1600. So 52 times 30. Nope, 1560. We're close. Not quite. Divide it off, x is equal to 78. Alright, next one. Why are the two overlapping triangles similar? Because we've got, this is 6 to 18. Because you've got two angles that match, so they have to be similar. Using right of proportion that models the situation, I've got 5 is to h, just like 6 is to 18. What is the height of the flagpole? I've got 6 times h is equal to 5 times 18. I can divide the 6 out of both sides and say h is equal to 15. So the height of the flagpole is 15. Alright, find the values of the variables. This one, a little dicey. It's all in how you describe it. I'm again going to think of similar triangles. So I've got my hypotenuse of the big triangle is to the hypotenuse of the little triangle. This little triangle right here. Just like the little side of my big triangle is to the little side of my smallest triangle. From here I can cross multiply and solve. I get 12a is equal to 36. So a is equal to 3. Same thing on this one. I've got my two legs. We're going to go 6 is to x, just like x is to 8. And it's my little leg. Well, you don't know for sure if it's little leg, but it's this leg to this leg on my little triangle, just like this leg to this leg on my medium triangle. I'm going to get x squared is equal to 48. So x is equal to the square root of 48. 16 goes in there 3 times, so x is equal to 4 square roots of 3. On this one, this is the same problem as this one. It's just simply rotated. It's been rotated on its side. So I've got 24 is to 10, my two hypotenuses. Big hypotenuse, little triangle's hypotenuse. Just like the big triangle's little side, which is 10, is to the little triangle's little side, because these are both similar triangles. So 24b is equal to 100. We'll divide that out. 100 over 24, and I'll get 25 over 6 to reduce. So I'm going to get 4 and 1 over 6. You don't have to write that in fraction form. You could probably say 4.2 if you were rounding to a tenth. But, you know, that all depends on how they want your answer. I'm going to say 4 and 6, just to be fancy. This one, I've got, oh gracious, I've got W plus 9 over 8, just like 18 over W plus 9. How fantastic is this going to be? Right here, we're going to take and we're going to cross multiply. So I'm going to get W plus 9 squared is equal to 8 times 18. This is going to be fantastic. 144. Going to have to do a little factoring today. So I've got W squared plus 9W plus 9W is equal to 81. Plus 81 is equal to 144. I'm going to combine everything up. So 81 minus 144 to get real quick is 63. W squared plus 18W minus 63 is equal to 0. That's going to be the 21 and the 3. So W plus 21, W minus 3 is equal to 0. So I'm going to get W is equal to positive 3. And I can throw out the negative 21 because if I dump a negative 21 in there, the length goes negative. Can't have a negative length. All right. Check out this next one. We've got a big, nice, long problem. Couple of variables. Here we go. First thing I want to do is I want to grab this side over here. Can I do that? We're going to cut the video. I'm going to take a look and we'll come back at it.